A very welcome to the Wandering Chemistry, and these all videos are promoted and financed by Fashionable Film City, Bollywood movie developers. A film city which going to be developed with the amount of 20,000 crore to 50,000 crore if government helps. Now in this video we should learn about molecular or vital method, that is MO method. Molecular or vitals method. The molecular or vital description of molecules is similar to the atomic or vital description of atoms. All the electrons in all atoms are considered to be separate from the nucleus and they are put one at a time into the atomic or vital, subject to Pauli's principle of increasing energy level by the quantum numbers N, L, M and S. The same process is also followed for a molecule. Let us consider the case of a H2 molecule. Each separate hydrogen atom consists of a proton and an electron. The electron normally occupies the lowest energy, that is 1s orbital ground state. In place of two separate 1s atomic orbitals, there are in molecule two molecular orbitals, sigma sub 1s and sigma sub 1s asterisk, each of which can accommodate two electrons. The sigma sub 1s molecular orbital is the lower energy state, that is bonding molecular orbital, and the two electrons in H sub 2 molecule with anti-symmetric spins usually occupy this bonding molecular orbital. At high temperature, the pair may be broken up and one electron may there be promoted to the sigma sub 1s asterisk molecular orbital, that is anti-bonding. The spins are parallel in this case. In the same way, 2s atomic orbital means AO, give sigma sub 2s and sigma sub 2s asterisk molecular orbitals. Within each pair, the bonding molecular orbital has a lower energy than the anti-bonding molecular orbital. Additional part of molecular orbital are obtained from 2p sub x, 2p sub y and 2p sub z. Now we see the bonding and anti-bonding molecular orbitals. Molecular orbitals are formed by combination of atomic orbitals of two atoms. In fact, when two atomic orbitals combine, they produce two molecular orbitals. One has less energy and the other more energy than combined energy of the two separate atomic orbitals. In molecular orbitals of less energy, the electron density is concentrated between the two nuclei and it is known as bonding orbitals. The molecular orbitals of increased energy concentrate the electronic charge away from the zone between the nuclei and is called an antibonding orbital, which has got to role in the formation of stable bonds between atoms. The bonding molecular orbitals are denoted by sigma, while the antibonding molecular orbitals are designated or shown by sigma sub asterisk. The asterisk mark is used to distinguish between the two types of molecular orbital. Now bond order. The bond order in a diatomic molecule is defined as 1/2 the difference between the number of electrons in bonding orbitals and number in anti-bonding orbitals. Thus bond order BO equals to 1/2 in bracket number of electrons in bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals, or BO equals to 1/2 open bracket NB minus NA close bracket, where NB number of electrons in bonding molecular orbitals and NA equals to number of electrons in anti-bonding molecular orbitals. When NB equals to NA, then BO bonding orbital equals to 0 and no bonds are formed. The bond order is 1 for a single bond, 2 for a double bond and 3 for a triple bond. Fractional bond orders are also possible. Bonding picture of simple molecules. The wave mechanical concept, that is molecular orbital model, presumes that two atomic orbital belonging to two atoms combine to give one bonding molecular orbital by adding them, and one anti-bonding molecular orbital by subtracting one from the other. Bonding molecular orbital is the state of lower energy, whereas the anti-bonding molecular orbital is that of higher energy. The latter therefore opposes bonding between the atoms. Two molecular orbitals are formed from two s orbitals, from one s orbital and one p sub x orbital, and two p sub x orbitals are sigma, and sigma is supersteric orbitals. Asterisk indicates anti-bonding molecular orbital. There is maximum lowering of energy when sigma molecular orbital is formed. The p sub y and p sub z orbitals are perpendicular to the p sub x orbital. Two p sub y and two p sub z orbitals can interact sideways and form pi sub py and pi sub pz bonding molecular orbitals, and pi sub py supersteric and pi sub pz supersteric anti-bonding molecular orbitals.